Unit 2, Part 3, In Behavior, Zeros, and Terms. And before we get too far into this lesson, we do need to cover just a review a definition for you. Well, hopefully you remember that a polynomial function is any function where you have the powers that are whole number powers. So ax to the n plus bx to the n minus 1 plus cx to the n minus 2 all the way down, and if you're in order, till the last term is a constant. So what we have there is, if this is a whole, all of these are whole number powers, that is a polynomial, and they're non-negative also. Whole number and non-negative integers. So positive whole numbers is the way to think of that. So anything like x to the third, or 2x to the 75th power, and it can keep going down. So plus 5x minus 1, all the way down. Those are all polynomial functions, and they'll always be continuous, which is good to know for future math classes. But let's look at what we have here. Just to kind of lead you into a concept here, we have x squared. Here's what the graph looks like. It turns one time. We were going down and going up. So the degree was 2, but there was one turn. Well, the cubic function has, here it's going up, turns and goes down, turns and goes back up. So it had a degree of 3, but there were 2 turns. Well, here's what a fourth degree polynomial can look like, and it was going down, then up, there's one turn, up then down, there's 2 turns, down and then back up, there's 3 turns. And it was a degree of 4. And same thing on this one, the degree is 5, because the power was 5, and there's 1, 2, 3, 4 turns. Well, hopefully, based on just that little example right there, you can figure out how many turns they can have. It doesn't mean they'll have that many, but at most they can have is always one less than whatever the degree was. So n minus 1 turns. It's based on the highest degree. So if this one was a 75th power and this was a 1, you'd look at the degree of 75, and that's how you know there could be up to 74 turns. Now there could be less, because you could have like a 4th degree polynomial could have 3 turns like this, or sometimes it'll look almost like a flatter parabola. So it only had 1 turn then. But at most it can have is 3 turns, depending on the degree. Now, hopefully you remember when we talked about zeros, well, that was pretty easy to spot. If it's an nth degree polynomial, it'll have n zeros. X squared functions have 2 zeros at most. Let's see, it's where it touches the x-axis, not just crosses, but where it touches. So it could be a bounce, and we're going to talk about that too. When does a function bounce and go back the other way? So, and you always, once again, we look at the highest degree, and whatever that highest degree is the maximum number of times that the function can touch the x-axis. Now, if it's written out long ways, all you got to do is find that power. But if it's in a factored form, we need to figure out what the highest degree would be. So this, I know, is a multiplicity of 2, which means that's going to make that an x squared, and that's going to be an x, and the last one's going to be an x. And if we multiply those all out, that's x to the 4th. So that one would have 4 x-intercepts at most. And when a function relating back to this example, it's right over here. This function goes with this picture. At x plus 5, negative 5 is the x-intercept, and it bounced, and the multiplicity was 2. Well, there's no power, which means it's a 1 automatically, so there was no other power listed. At positive 1, because x minus 1 equals 0, you get x equals 1. X minus 4 equals 0, you get x equals 4. Those cross the x-axis. So the lesson learned here is when it touches the x-intercept and bounces, like if you look at this function, it was going down, bounces, then goes back up. So if it doesn't cross where it touches, that's when you have an even multiplicity. And it crosses when you have an odd multiplicity. So, reviewing all those traits, let's see what we can come up with on number 1. This function is not in order for highest degree polynomial. So find the highest degree. It is a polynomial function. It's not in factored form, so the highest degree is 6. So there could be 6 zeros, and there could be up to 5 turns. So let's see. Look at number 2. Determine the zeros, the multiplicity, and the end behavior. Well, something else to know about for end behavior, we haven't talked about that yet. The end behavior, if you have a positive even, you're going to go up on both ends. If you have a positive odd, you're going to go up on the right and down on the left. If you have a negative even, you're going to go down on both ends, so down on the right and down on the left. And if you have a negative odd, you're up on the left and down on the right. Well, I think that is, if I remember correctly, that's right here on the back. So I'm going to go answer these, then we'll go back and talk about that. So in behavior, you have to look at the highest degree, and you look at the leading coefficient. I may not have specified that. So, and really look at the right side first, because if it's positive, the right side is going to be up, no matter whether it's even or odd. And then if it's odd, well, if it's, let's talk about it. If we said positive, it goes up on the right. Negative, it goes down on the right. Now, if it's odd, the ends go opposite directions. If it's even, the ends do the same thing. So this one was down on the right. Since it was an odd negative, it's up on the left. So negatives go down on the right, positives go up on the right, evens do the same thing on both ends, odds do the opposite on both ends. So let's go back to the question down here at the bottom. Number 2, determine the zeros. Well, this one's already in factored form. So I look at this function right here, and I look at the first one. Negative x equals 0 means x equals 0. That's one x-intercept. X minus 3 equals 0 means x equals 3. And x plus 2 means x equals negative 2. Those are the 3 x-intercepts for this function. And this was a degree of 1, this was a degree of 1, and this one's a degree of 5. So the multiplicity was 5 and 1 and 1 for each of those. So if we know we're going to have an x-intercept here at 1, at 0, an x-intercept at 3, and an x-intercept at negative 2. And I know if I look at what the coefficient would be, this is a negative 1 times 1 times 1 to the 5th power. So 1 times 1 times 1 times 1 times 1. That would be a negative 1 leading coefficient. So the leading coefficient is negative, which means down on the right. And as long as they were an odd multiplicity, they pass through and don't bounce. Well, all of these had odd multiplicity, so odd degrees is another way to look at that. So this means it has to pass through. I don't know how high or low to go. It could be up here. It could be very barely. I just know the general shape. I know. So let me clear this off and we'll talk about that again. I'm going to just undo a couple of marks here. I know somewhere here it's got to turn around and go back up, and it has to pass through. So it's an odd negative, it's odd power, a negative leading coefficient, and it was 5, 6, 7 was the power, so the ends are going in opposite directions, which is what we had. So up on the left and down on the right. So I knew it went down on the right because it was a negative leading coefficient. So now we're going to do the other way around on number 3. This one is factored already, so let's find the x-intercepts. One x-intercept is x equals negative 1. The other x-intercept is x equals positive 2. Well, so our factored form, move that back to the other, it'd be to the other side of the, and it'd be x plus 1. And this one would be, the second one would be x minus 2. Now, I know it's down on the right, so I don't know what the value is at the current time, but I know it's negative. If we want the value, we would have to pick another point like the y-intercept, and we put an a here, and we can actually solve for it. Let me check to see, do we need to solve for that? I'll tell you very shortly. I went and compared with the key. In this one, we weren't looking at actually finding the value yet, so we did not solve for it. So we just know it's negative, and it bounced at negative 1. I didn't catch that. So it bounced, so that means it needs to be an even multiplicity. So we'll go with the lowest power, which is 2. So what we have right now, let me take out my scribble marks. We had f of x equals negative x plus 1 to the squared, x plus 1 squared times x minus 2. And that's all we can do without going into more detail. That gives us the rough shape. We know we passed through at 2, we bounced at negative 1, and we know it was down on the right, so it had to be a negative. We're going to do the same thing on number 4. So this one touches at negative 3, so that means x, it passes through at negative 3, so that means x plus 3 would be the factored form. And it's an odd power, so we're going to use the smallest odd power, which is 1. The next x-intercept is positive 2, and it bounces, so that is an x minus 2, because we had to change the sign, and since it bounces, we need an even power. And then the last one is x equals 5, so that'd be x minus 5, and it passes through, so we're going to leave an odd power of 1. It's up on both ends, so we need a positive, so we are done with this one. We're just going to put an f of x in front. Like I said, if we wanted to actually figure out what if there was an a value here, we would need another point like the y-intercept, and we can actually solve that, but we're not going to on this part of the lesson. Right now, we are just getting general shapes of direction and what the factored form looks like. Well, I lied to you. This one we did actually figure out what the a value is. So there's technically some a value here. So let me clear this off and try to write a little neater here. Let's see if I can get it cleared. Okay. So I'm going to try to switch to a finer point pen here. And we'll start over. We had f of x. Whoops, sorry, didn't mean to hit somewhere else. We know it's an a value that's going to end up being a positive number, and we had x plus 3 because that was x minus 3, and we had x minus 2 that had an even power, and we had x minus 5. Well, since we know that this passes through the ordered pair 0, negative 2, we can actually find out what this value of a is by plugging in 0 for x and negative 2 for y into this function. So what we would have is negative 2 right here is equal to, I don't know what a is, we're going to solve for a. That's an a, not a 9. And we put in 0 for x, so 0 plus 3, 0 minus 2 squared, and 0 minus 5. Well, that's going to give me 3. So a times 3 times negative 2 squared is positive 4, and then negative times negative 5. So we end up with negative 2 equals a times 3 times 4 times negative 5, which is 12 times negative 5 is negative 60. So negative 60a is equal to negative 2. Divide up both sides by negative 60, and you get 1/30th is our a value. So that means this function in factored form would be f of x equals, we now know what a is, it's 1/30th. And then we'd have x plus 3 and x minus 2 squared. And lastly, x minus 5. And there would be the factored version of that. I do not believe we want to multiply it out. I'll double check. We did not multiply it out, so we're done with the front side. So let's go on to the back side. Well, we've already talked about the degree and the in behavior based on the degree and the leading coefficient to decide whether it went up on both ends or opposite on both ends. So let's look at some examples of this one. So number 5 says find the degree, the leading coefficient, and the zeros of a polynomial function when we have f of x equals x to the 4th minus 36x squared. Well, let's factor that. And I notice that that has a factor of x squared in common. So if I factor out an x squared, we would get x squared times, well, x to the 4th divided by x squared will leave me an x squared, and negative 36x squared, if you divide out the x squared, leaves you negative 36 there. Well, that can be factored to, that's the difference of 2 squares. So we have x squared, and we have x plus 6 and x minus 6. There's our factored form of this function. So now I know the zeros. State whether the graph crosses, touches the x-axis, and then describe the in behavior. Well, it was a positive leading coefficient. We already know the in behavior. It's going up on both ends. So as x goes to negative infinity, that means as we go left forever, the y value is going upward to positive infinity because it was a positive even. Positive even means up on both ends. So if we were to draw a picture, that meant we were doing that to the left. And then as x goes to the right to positive infinity, which you don't put a positive, you can, but positive infinity, the function's still going up. So that means it's going to positive infinity again. That means up on the right. And for the x-intercepts, the first one is x equals 0. And it's an even power, so it touches. And then the next one is x equals negative 6. And it was an odd power, that's power of 1 out here. And so it crosses the x-axis. And same thing for positive 6. This is x equals positive 6, and it crosses there and not touches. So we told whether it touched across the x-axis, we found the x-intercepts, and we described the in behavior. We finished number 5. Let's look at number 6, which is the same style of problem, but it's already factored. So The degree, to find the degree, I need to look at what all these x terms would be, since this one's factored. If we multiplied it out, we would have a negative x squared times an x to the first, because of the power of 1, times a 2x times an x. So that is 1, 2, 3, 4, 5 x's. And a negative 2, that would be a negative 2x to the fifth. That tells me it's an odd degree, so the ends are going to be opposite directions, and it's negative, so I know it's down on the right. So this graph goes up on the left and down on the right because it was odd. It has to be opposite directions, and we knew it was down on the right because the leading coefficient was negative. And so if we wanted to write that, we would say, as x goes to negative infinity, f of x, the y value, goes upward. As x goes to positive infinity, the y values are going downward. That's the same thing as what these arrows are describing. Now, it's already in factored form, so all we have to do to find the zeros is set each factor equal to 0. Well, negative x squared equal to 0 means x equals 0. You can take the square root and divide by negative 1, you still get just 0. No plus or minus on that one. And you get x equals 5 for the next one. And 2x plus 1 equals 0. You would subtract 1 and get x, and divide by 2, you'd get x equals negative 1/2. If you need to see that, that is, where can I write that? I'll write that up here. 2x plus 1 equals 0. Subtract 1, you get 2x equals negative 1. Divide by 2, you get x is negative 1/2. And then last one is 2 plus x equals 0. If you subtract 2 from both sides, you get x is negative 2. And now, the only one that had an even multiplicity, this was a 2, a 1, a 1, and a 1. So at 0, it bounces or touches. The rest cross. So all three of these cross the x-axis. Instead of writing it 3 times, it's going to be. And that is number 6. So let's move on to all parts of number 7. On number 7, the first one on 7a, the degree, we have to find the highest power. And the highest power is 3. This one's not factored, so we look for the highest power, and that was the degree of 3. The leading coefficient is the term in front of that highest powered term, and that was a 5, so it's a positive leading coefficient. And then the most number of zeros it can have is whatever the degree is, which is 3. The terms is always 1 less than that, so there could be 2 terms at maximum. And since this was an odd degree, the ends go opposite directions, and it's positive, so it goes up on the right. So this means to the right, so this would be up, so that means infinity. Since it's odd, the left end has to do the exact opposite, so this is going downward as x goes to the left. Okay, let's move on to 7b. On 7b, it's in factored form, so to figure out the degree, unlike this one where we just look for the highest power, this one we have to multiply all the x's together to see what you'd get. Well, this is 1x times 1x squared, so x times x squared times another x. That is x to the 4th, so it's a degree of 4. And the coefficients on those would have been 1, 1, and 1. 1 times 1 squared times 1, this was also squared, would have still been positive 1. So the degree, since the degree is 4, the maximum number of zeros is 4. The maximum number of turns is 3. And it's an even degree with a positive leading coefficient, so that means up on the left, that's up on the left and up on the right. So that means positive infinity as we go left. X is talking left and right, x going to the right, and this is positive, so up on, but the f of x are the y's. So f of x was going up on both ends, and that's all we need to do on number 7. So let's 7b. Let's go to 7c. This one was an 8th degree polynomial because it was all written out and it was going down in power, so the dot, dot, dot means it doesn't care what the middle, we don't care what the middle stuff's doing. I know the highest power is 8, so that tells me the maximum number of zeros is 8, and the turns are 7. And it's a negative leading coefficient. Well, even power, degree, means same on both ends, and negative means down on both ends. So it's down on the left and down on the right. So as x goes to the left, as x goes to negative infinity, we're going down. As x goes to the right, y is going down also. Okay. Last two, we're going to sketch what we know is going on here. Sketch the graph of a polynomial function which has a positive y-intercept. So, okay. So positive y-intercept means up here above the x-axis, one local max, one local min, but has no absolute max or mins. And it goes, y goes up as x goes up. So one local max, but no absolute max means it has to have somewhere there's a top of a hump, top of a mountain here, top of a hill. So let's see, one local max and one local min. So it means it has to do, and it has to, when we say no, it has to go up to the right. So it has to do that. Well, there's a local maximum, there's a local minimum, and I can't have any more, and it can't be the lowest point on the entire graph. It has to keep going down forever then. So one local max, one local min, no absolute max or min, and it crossed the y-axis at a positive number. So I would go with that picture. Is that the only graph? No. We could have, it's the general shape. I know it's got to be down on the left and up on the right, and do this, but where it touches the y-axis, as long as it's somewhere, it has to touch the y-axis at a positive number. So it could have been here. It could have been here for the y-axis, as long as the y-intercept is somewhere positive. So any one of those. Number 9, sketch the graph of the polynomial function which has a negative y-intercept, so we know it's going to touch somewhere below down here. So we're going to put it a negative value on the y-axis. One local max, one local min, and no absolute. And it says as x or y goes down as x goes to the right. So we have to be going down this way. And if there's no absolute, that means it can't have a maximum, so it has to be going up somewhere over here forever. And one local max and one local min. So somewhere we have to pass through this, and we have to have a bottom of a hill and top of a hill. So I could do this even. There's one with a local minimum, a local maximum, no absolute because it goes down forever, no absolute max, no absolute minimum, no absolute maximum because it goes up forever. So there is everything you need to be able to do this assignment. Good luck to you.